Meeting is being recorded. All right, I think this is working. Thanks, everybody. This is Dave Webb from the Maryland Biodiversity Project and from the Left Club and various other NHSM related awesomeness. And after he's done, there's time for questions and then we can mingle, and there are snacks in the back, so feel free to have some refreshments. And so you did.
Okay, showtime. All right, thank you all for coming out. This is a nice crowd here. First of all, I am a mother. I really don't do butterflies because I have to sleep in the daytime if I'm going to be a mother. My training consists of a couple of classes. I'm not professionally trained. I do not have an entomology degree. But I have thousands of hours in the field and a passion for doing this. So I love, excuse me, I'm a lousy daytime photographer as well. But nighttime photography is not that bad. There's only a few little tweaks you have to occasionally do with your camera settings. So although I feel that I've learned only a tiny bit about moths, I'm happy to share a few things with you tonight that I've learned in the last 11 years. I've been a birder actually for over 35 years. That's where I started my outdoor study. And there it's almost instinctive to identify not just what bird you're looking at, but you want to know, is it a male? Is it a female? Is it a juvenile? So it's kind of natural for me, now that I've been mothing for a while, to ask the same sort of questions and try to figure out, am I looking at a male moth or a female? So when you have 2,900 species of Lepidoptera in the state of Maryland, it's a pretty daunting task to want to learn about all of them. So I understand why some people don't really do much when it comes to sexing moths, but maybe after tonight, you'll feel a little more relaxed and maybe you want to do it. So here's where we're going to start. I'm going to look at an example of a moth. This is the pale.
You move the panel of participants over on the far right side of the screen.
To the right side?
The names
Oh, sure. Sorry.
Hit the
Can I
hit the minus button on the far left, right there. Right there.
There we go. Okay.
Thank you.
All right. So pale beauty is a very common moth in eastern North America, excluding Florida and Georgia, goes all the way up into the maritime provinces. There's a little connecting strip through southern Canada where it reconnects with the West Coast population. And in iNaturalist, there's a way that you can find out how many just adult observations have been made of research grade. Research grade just means the person who submitted it and at least one other person, or maybe it's a majority of people who respond to the observation agree with the ID. And for pale beauty moth, it's a pretty easy moth to identify. It's in a subfamily of the geometers, Anomone, which has, I think, over 700 species in it, and yet it is the only member of its own tribe. So there's not a whole lot you could confuse it with. And the IDs are very reliable. So I was curious, how many of these records did people annotate as being females? And that number was only 39. I said, okay, well, maybe the males are easier to identify. How many of those? 63. So out of over 20,000 good observations of this moth, only 100 of them, that's about half of 1%, did people annotate on the page that it's either a male or a female. Here's what the moth looks like, close up. Photos that I took, and you can see that these look pretty similar. There are some differences. One is a male, one is a female. Anybody here, can you tell which is which? Let me help you. Let's zoom in and look at the head. What do we got? The one on the right is a female, and the one on the left is a male. The male has what are called bipectinate or feathery antenna, whereas the female's antenna are filiform or thread-like. We'll get into descriptions of the different kinds of antenna a little bit later. So it's not a hard moth at all to identify to its sex. Just get a decent photo that shows the antenna. And even if you don't see the entire antenna, notice how on both of these pictures, the antenna were tucked underneath of the forewings. But you see just enough of what you need to see right there. All right. So here is what we are going to be covering tonight. Three main topics, kind of, I could have called this sexual dimorphism, but we'll get into the specifics of secondary sexual characteristics a little bit later on. We'll start off with kind of a holistic view, just looking at the moth as a whole. Are there ways that we can tell males from females apart? And the answer is yes. 3 ways to do it. We'll go over them. Then for those who collect, and you have an opportunity to look at the moth up close, either naked eye, with a loupe, maybe you put it under a microscope, and we'll discuss some of the ways that you can determine male or female there. But what about for the person who is kind of like me? I'm a photographer. Very little of what I see do I actually collect, take home and collect. Are there ways that you can look at your photos and determine what you have? And the answer to that one is yes. There's a lot of ways you can do it. So we'll start with the holistic view. And we'll start with coloration and maculation. So this is about as different as you can get for a male and female coloration. This is our Io moth. It's one of the Saturniids. Male is on the left here, female on the right. And to me, the male is obviously a nice lemony yellow color, and the female, she looks like sliced bacon, that ham color.
It's not.
But when both of them spread open their forewings, and you can just see a little bit of it here, they got those big eye spots on the hind wings. So that's a very easy example. But it doesn't necessarily have to be a large moth. There are some very obvious sexual dimorphism in this particular species, the yellow Spraguea moth. That's in the family Noctuidae, and it's the female here that has the black streaked band, very wide, running across its body. As the plumage becomes a little plumage, there I said it. As the coloration becomes a little more complex, you might have to look a little bit harder. And just with the naked eye, you can see something's going on here. The female on the bottom is much darker, but where are those darknesses? And what I like to talk about for this particular species, the bent line carpet moth, is that the male, I'm going to move that out of the way. There we go. Has a very prominent spot on each forewing that is against a pale colored background. That black spot still is there for the females, but you can barely see it because she has a very broad, dark band across her forewings. Oops. All right. Then we can talk about this particular example here. It's called the bee moth. I'm going to get rid of that, Matthew. There. Okay. This is kind of a cool moth because the caterpillars live inside of beehives. Pretty bold, huh? So here's where the phrase or the term maculation comes in. Maculation refers to the spots, the markings, the stripes. And here, the difference between the two is more the maculation than it is coloration. Yes, there are some color differences here, but you can see that the spots on the female on that forewing stand out much more. They're larger than the spots that the male has, which are kind of hidden. All right. So that's all I want to say about coloration and maculation. That's not that hard. You can look up any field guide and learn that kind of stuff. All right, now let's talk about size differences. Rule of thumb is females tend to be larger than males, right? Not just their abdomens, which are often full of eggs, as you can see here. That is a female top, but they tend to have larger wingspans, longer bodies. Not always the case. So, next example. This one, American lotus borer moth, a very obvious size difference. There's even arguably some coloration difference. The female, the presumed female, I'll get into that, on the right is brighter. I cannot find a reference where I get actual measurements of males and females and what that should be. So while I'm not 100% sure that I don't have an oversized male on the right, I think we're probably correct in assuming that that is a female on the right because of her larger size. All right, here's another example. Common tan wave moth, another geometric. The size difference here, can anybody see one? Which one looks like it might have a longer wingspan, top or bottom? Yeah, by just a little bit. I mean, we're talking 5% difference. So you might think that's the female, right? It's the male. If we look close enough, look at his antenna. Look at her antenna, okay? He's got the bipectinate, and she up top there has the filiform antenna. So
Person on Zoom is right. Kay called it.
who got it?
Hey, Monterelli.
Very good. Okay, you get a beer.
Over to.
All right, so now we'll talk about another thing that you see just looking at the moth, and that is whether it's winged or not. All moths have wings, right? Nope. Nope. There are some moths where the females don't have wings at all. Or maybe they have very stunted wings, but they still can't fly. Here in Maryland, we have 12 species where the moth or the female is completely wingless, but the male, he looks like, regular old moth. So that includes the bagworms. I didn't put pictures of the adults, but everybody's probably familiar with the evergreen bagworm, very common. Has anyone ever tried to rip one of those apart? Oh man, yeah, I can't do it with my bare hands. It is really, really strong. I've only seen one person. Yeah, next meeting. Right? The moth in the middle, quite common. That's Orgia, which are the tussock moths. That's the definite tussock moth. Let's take a look. Oh, and the ones on the bottom are the geometers where the female's wingless. They're the three cankerworms, the Bruce spanworm, which is also known as a winter worm occasionally, and one that might actually be extirpated from Maryland, the Linden looper.
Why is it called the definite tussock moth? Is there like a probable tussock moth, or pretty sure it's a tussock moth?
I will look that one up.
You don't need to stop me.
No, I've done not now. Okay, so let's take a look at what the females do look like, though. So, oh my God. When I first looked at that photo, I thought it was a flea. That is an adult female common bagworm moth. How about the definite tussock? What's that female look like? Okay, maybe not a flea, but I'm not sure. It's the white object here. And she is laying eggs. Okay. This moth, the females always stay near their original cocoon. And so she's laying eggs around her cocoon, and then she deposits this white foamy spray that will protect them over the winter. And finally, the fall cankerworm, that's one, I don't know, looks like an isopod almost to me, but that is a female adult moth with no wings whatsoever. All right. Then we have this odd moth called a half-wing. And in this case, the males are full winged and the females have a reduced wing. Not much of a wing, and it's certainly not enough to fly. So anyone who tries to attract moths on a nice warm January night when the temperature gets up around 45, 50 degrees, you turn your porch light on. This particular genus is the one that is probably most likely to show up, Phagelia. So half-wing is one of the Phagelias. And here is what the female looks like. Like she's got a shawl across her shoulders. But those wings are not enough. And then here's a case where the female has full wings, but the male has reduced wings. And it's called the notched-winged wave moth. The photos here give you some sense of what might be going on. Female is on the left, and she has very broad wings, but you don't see anything otherwise unusual about it. The male who's on the right, you can see how abbreviated, if you will, the wings look like. And you really notice it if you were to look at specimens. Yeah.
We knew this was gonna happen.
Mm-hmm. Yeah, we're having issues with the hyperlinks. All right. Oh, because I didn't hit the control. And I gotta go to the slideshow. Yep, thank you. Slideshow from current. All right, now it should work. There we go. All right, I'm going to scroll down. So there are pinned specimens of the female on the left and the male on the right. I mean, they look cleft to me, right? Yeah, kind of like mittens. But you notice that it's not only the hind wing, but the forewing also is reduced in the male. So very uncommon. I have not come across another instance where the female has the full wing and the male has a reduced wing. All right, so that's it for the holistic view. Now let's go to means for sexing specimens that you have collected and you have them in hand. And for the folks who do this, maybe you're already familiar with the frenulum technique. And we'll go over just very briefly genitalic dissection. I don't think I'm going to say much, if anything, about sternite brushing. All right, so we have 2,943 species of moths and butterflies in Maryland. And I'm going to partition them in a certain way. So we have the butterflies and skippers, all of them, and a certain superfamily, the Bombicoidea, which includes sphinx, saturniids, and silkworm moths. Another grouping is going to be a very small one. It only has 6 total moths. Hepialoidea and cranioidea. I only have to say that once. So those total is fairly small. Everything else is over 2,700 species. Over 90% of the species are in this final category. Well, what is that category? I am not going to explain to you what jugal and amplexiform wing coupling is, but we will talk about frenate wing coupling. And camera time. There's my little. There's something fall on the floor. The ring. We'll make it work somehow. I'll take it. All right. So, camera. Moths have 2 wings on each side, right? And they can't be flying like this. Stoneflies. I think stoneflies. Yeah. But anyway, moths, and butterflies, they want to fly with those wings in unison. So it's these 3 coupling techniques that I'll talk about that keep the wings together. And here's how it's going to work. Imagine that this hand is the forewing, and here's the hind wing that sits underneath them. So this little pin here is going to loop through this ring I have on the forewing, and once that's done, now they're in unison. Okay. So that's the frenate wing coupling. Here's maybe another way to look at it. And this is more accurate than pipe cleaner and a long toothpick. So in blue, it would be the forewing. And now we're looking from the underside. All right. So you have this little pocket. That pocket can be a loop. It can be several loops that's attached to the bottom of the forewing. And this little bristle called the retinaculum comes off of the base of the hind wing. So that was my little toothpick that I was using there. And when the moth comes out of the cocoon, that hind wing is already through the retinaculum. Okay? It's all ready to fly once the wings expand. Males have a single bristle for their retinaculum. For most moths, not all, but most, the females have more than one. So when you look at your specimens, you turn them upside down to look at it from the bottom, and you look at the base of the hind wing and the forewing, you might be able to see this. You usually are not going to see this in the field, okay? But guess what? Miracles do happen. A few years ago, I took this picture of a white spring moth. It was right about this time of year, 4/23, 3 years ago today. And when I got home, I was looking at the picture a little more carefully. And I noticed, okay, here's my hind wing. I'm going to blow it up. What do you see? Do you see this single bristle, the frenulum, passing through the retinaculum? That's a male. So if you have a light colored moth and it raises its wings like that, you have a chance to maybe determine its sex. And yes, the white spring moth male, I believe, does not have, it has filiform antenna just like the female. All right, so there we figured out it is a male. Now here's another one. Took this picture a couple years ago, and it was a damaged moth. This is a tortricid. Tortricids are one of the kinds of moths that hold their wings in a tentiform fashion. Okay, they don't hold them flat, they hold them at an angle so the wings touch each other over the back. So it really makes it hard to get a picture of the underwing, right? But this moth was having a bad day. That wing coupling had become disengaged somehow. And now that hind wing was sticking straight up. So some sort of traumatic event caused that to happen. Once that wing coupling is disengaged, they don't put it back. It's like that forever. So this moth would probably not have lived too much longer. Yes.
Actually see the little, yeah.
There you go. Okay, so we're going to zoom in now. Do you see the frenulum? How many bristles is it?
3.
It's a girl. That is a female tortricid, large aspen tortrix moth, Caristonera conflictana. So that is a pretty rare thing there, to be able to sex a tort just by a photograph. Genitalic dissection, it's critical for researchers, for academic research, okay? And I'm not one who does dissection. I figure I could spend, it takes me a while to do one. This is the one that I've done. And this was a male. The way you can tell is that the genitalia almost look like an inverted saddle, okay? Females, and this will be a maple, uh-oh. Oh, there it is. The female here, I don't know how to describe that. Maybe a vacuum cleaner bag that's been constricted a couple times along the way, but it doesn't have the same shape. Genitalia are different from species to species. That's why academics, collect to determine what species they have, because a lot of times you can't tell with, your eye. So, yeah, my point is it can be done. I applaud those who can do it. I just don't. So, okay, I'm going to skip any discussion on the sternite brushing. It's another way to determine, well, to be able to see whether you have a male or a female, but really it's more for species identification than it is for sexual differentiation. Now we're going to get into the good stuff, the secondary sexual characteristics. Jason Dabrowski at Cornell, who happens to be on the phone, right? Hi, Jason. He's there. Okay. Defines it as pre-mating stimuli, not directly involved in the mating, the copulation. And it entails anything that you're talking about, chemicals, the pheromones that are emitted. And if anybody has a youngster who wants to go off to school and become an entomologist, boy, if you combine that with chemistry, there is so much cool stuff being done in that area of learning about what are the chemicals, what are those pheromones that the moths are giving off. A lot of cool things that I've heard about that. You have the behavior. How do the males and the females act? What is the courtship before they mate? And then you have the morphological differences. My camera cannot really pick up the chemicals very well. I don't take video, so I don't capture behavior.
Smell-o-vision?
Nope. But I can pick up morphological differences that are secondary sexual characteristics as well. So that's what I'm going to present to you now. And we will discuss antenna. Antenna play a critical role. Labial palps. And those are the palps that you see that come forward from the head. They don't always just go forward. Sometimes they go up and around the back of the head. We'll see some pictures of that. Androconia, we'll get into that. Fovea, coromata, and I don't think I'm going to talk about epiphysis, but let's do this. Here's the nerdy part. We got to talk a little bit about antenna anatomy. Okay. This is the antenna of a Polyphemus moth, taken from a German paper 60-some years ago, and I still think it's the best drawing of antenna. So the antenna can be thought of as a main stalk. Okay, that's the scape, which is the basal element of the antenna. The next one is the pedicel, and then everything else beyond it. Those are considered the flagellum, and they're viewed as those three components because only the pedicel and the scape are jointed. Okay, so any movement of the antenna is from the base. You won't see antenna bend. If a moth has like branches that come off of the flagellum, those are called rami, R-A-M-I. So think of them as like side branches. Oh, and the flagellum, all the little sections of the flagellum, they're called annuli. So if I look at now, zoom in to the middle where the artist did. You're looking at just 2 of those annuli, numbers 20 and 21. And you'll notice that the branches coming off of there, those are the rami. You're just looking at the basal part of it. They don't show the whole thing. And then here's another thing that we didn't see on the left, but it's critical. These are the sensilla. These are the actual detectors, if you will, that the moth uses to pick up scents, odors out in the wild. Okay, does that make sense? It's almost like it has a botanical similarity, right? Branches. You think of. They can. Yes, that's what we're going to talk about. All right. So this is probably the most complex kind of antenna that we see in moths, and they're called quadripectinate. And what that means is you have 4 of these rami coming from each annulus, or each annulus section. All right. 4. It's the same thing that a Luna moth. Surprise, surprise. Luna and Polyphemus are in the same family, right? Okay, so Saturniids, most of them have quadripectinate antenna. So what I want to do is bring up the male's antenna for the Luna moth and the female. There are 2 important differences here. What do you notice? One's obvious and the other one's not as obvious. Okay, so those rami, the side branches, they look longer in the male in general, right? They still taper quite a bit as they get towards the end. There's another thing, and I hope you can see this at home. Should be able to see it on the screen. Compare the different lengths of the rami. The male's rami are, every pair, they're of the same length. The female, you have a long and a short. So if you go home and you look at your photos, or if you have any Luna moths, that you've collected, take a look at those antennae for those differences in the 2 lengths of the rami. Okay, now we get into the different types of antenna for all of Maryland's leps, the butterflies and the moths. Butterflies have capitate, right? Clubbed antenna. And that is a rule of thumb that, at least in Maryland, holds. There are some moths in the rest of the world that do have clubbed antenna. Moths generally have pectinate antenna, serrate, which is the saw-like, or filiform thread-like. The pectinate just means comb-like, and it can be unipectinate, where the rami just come off of one side. It can be bipectinate, where they come off on both sides, and it's only 1 pair per annulus. Or, like we saw with the Saturniids, it can be quadripectinate, 4 rami coming off of each annulus. And then you have the clavate, which are the club-like antenna. To me, that looks like a hockey stick, whereas the capitate looks like a driver, a 3-wood. But clavate can be among some moths and some butterflies. It's the only shared antenna type. So I wanted to point out what I feel is I hope I got this. Yeah. All right, so this is from a web page that came from New Zealand, where they're talking about antennal differences, and they mention the differences between moths and butterflies, and then males and females. And it says moth antennae are thread-like and feathery and taper to a point. Maybe. This differs from the butterflies, whose antennae are knobbed. Okay, that's the same here. So these are the antennae of a female and male moth compared with the antenna of a butterfly. You might walk away thinking that all male moths have pectinate antenna and all females have filiform. No way. We've already seen one exception with the Saturniids, right? So Here's what I would say is more truthful. When the antennae are sexually dimorphic, it's the male's antenna that are more complex. However, there are many species for which either both of them have pectinate or they both have filiform antenna. So when they're both pectinate, we still have a pretty reasonable chance of figuring out who's the boy, who's the girl. When they're both filiform, not quite as easy, but there are some things that we'll see that are helpful. So here's just one example of a moth where both the male and the female are bipectinate here. This is from the family Lasiocampidae. It's the dot-lined white moth, very common in the fall. And again, the male has the longer rami in the basal half of the antenna, whereas the females are pretty much consistent length throughout. Just one example. This is a different family, Mimilonidae. There we go. The scallop sac bear. And here the male has what? How do we describe that one? Bipectinate, right? Whoops, was there something on? Oh, yeah. And we'll, I'm sorry, that's the female. That's the female that we're looking at. And there's the male. So this is kind of like that case that we saw with the dot-lined white, where the rami are much, much longer on the male. Oops. Pale banded dart. This is one of our noctuids that we see in the fall. And both of these are males, but I would put them up here because if you don't look at that bottom photo too carefully, it looks like it's unipectinate, right? But what happens is, instead of those, the rami coming off at like completely opposite sides, 180, they're slightly angled or dihedral. Think of a turkey vulture. So that depending upon what angle you come in with your camera, you may see the long side of one half of the antenna and the very, very short side, or maybe even nothing at all on the right. So the caution is sometimes you might think you have unipectinate, but you actually have bipectinate. So it's a good idea to take a couple camera shots or just different POVs to be certain. You can barely see. I'm gonna a little bit. On the top, you see full length, but you just barely see a little bit there. That's just because it's a two-dimensional image of a three-dimensional object. You don't always get the right picture. Harris's 3-spot. I love this moth. Very colorful, even for a brown and black moth. This is the male, and I put this up because this is an example of serrate antenna or saw-like. You can see that in the blow up on the right. Look like the teeth of a butter knife. And then the female, she looks like, oh, come on. Bug guide was crashing a couple of days ago. Oh, there we go. So the female looks otherwise identical to the male, but her antennae are filiform. I would say fairly thick filiform. All right, now here's where we start to get into some of the cool stuff, where both the male and the female have these filiform thread-like antennae, but we can still tell them apart because of certain features that the males have. And the feature in this case are nodes. It's like a swollen section of that filiform antenna. You'll see it on the male on the right. Female does not have it. Here's another one, the discolored renia. I'm pretty certain that all the renia are like this, where The node is a little bit farther out on the antenna. That's okay. But it is there. Female is perfectly filiform. Now we get into a species within the family Crambidae that is a kind of notorious for presenting ID problems, but it's not that bad. If you know how to take the picture, capture the moth in a Ziploc bag. Don't crush it, but get as much of the air out so that the moth can't fly around in it. You won't harm it at all. I've done this scores of times. Turn the bag over. Now you're looking at the belly. So to tell whether you have Desmia funeralis or its sister species, Desmia maculalis, you want to look at the white patterns on the abdomen. But to tell if it's a male or a female, you'll see that you have quite a large swollen area on the males. So it's a node, but it also has a notch in it as well. Very different from the female's filiform. This is a tortricid. And as I mentioned, tortricids, I just got really lucky that time where I got to see the moth that had the damaged wing. Most tortricids, you cannot tell the males from the females unless you look at the wing coupling or you do genitalic dissection. There are some exceptions. So one is this genus Pandemus. We have two of them in Maryland, Limitana and Lamprosana. And they have, on the males, do you notice anything unusual? It's got a little notch right down near the base. And I'm not actually sure if that is the second segment of the pedicel, or if it's in the basal section of the flagellum. But anyway, that actually has a courtship function in the foreplay. Before they mate, the males and the females, they rub their heads together, and it's believed that somehow this notch is playing a role in the female's acceptance of the male. So if you have pictures of these Pandemus moths, look at them real carefully, because you might see that some of yours show that notch. And if you do, you got males there. So a couple of weeks ago, I was up in New York with Jason Dombrowski. He was very generous, allowed me to stay with his family, and I got to go into their museum. And I took this picture of a moth that had been collected about 86 years ago in Texas. And it's from the genus Strepsicrates. It's a bayberry leaf tire moth. It's another tortricid. As the name implies, its host plant includes bayberry. So you only find this moth in Maryland on the shore or the tributaries of the Chesapeake. If you look at a distribution map for Maryland, there it is. It outlines the bay. So this species also has a notch in the antenna for the males only. So what I'm going to do, now we're going to iNaturalist. And here is a photo that Tim Reichert, he's arguably the best mother in Maryland. He's very, very good. Finds a lot of good stuff. In fact, I think today he just added a new species to Maryland. Yeah.
How do you?
It was announced on Maryland Biodiversity Project's front page. Yeah. So if I zoom in really close, can you see that at the base of the antenna, there's a little bit of curvature? And where that curvature just starts to straighten out, do you see that notch there? That's a boy. Okay. So I will go into iNaturalist when I get home tonight, and I will annotate Tim's observation, letting him know that this is a male. And that goes back to a book that Jason was letting me look through that was written 100 years ago. Yeah, pretty cool. All right, we talked about labial palps. Okay, so the palps are sensory organs that are just below the eyes on the face. And for most moths, they will extend forward. But in this particular genus from the family Teniidae, Acrolophus, males and females, most of them, have very long labial palps, and the males hold them high up over their head. And that position is called recurved, whereas the females hold theirs porrect, just straight out towards the front, mostly horizontal, but you'll notice there's a little bit of a crook in her labial palps. There are pheromone receptors that the male has on his antenna, so it's believed that he can detect her pheromones better if his antenna are in a higher position. And it's, pardon, recurved. Recurved is the posture. Yeah. And this is characteristic of pretty much all of our Acrolophus species in the state. So because this is a species where it is tentiform, which I used before, where the wings are held in this V shape, I always take my pictures of these guys from a lateral position so that I can see what that side or what the wing looks like, what the pattern is. That's really crucial to figuring out which of the Acrolophus you have. For some species, Palthus, that's in the family Erebidae, they also, either the females hold their labial palps forward or the males hold it over their head and like towards the back. But the problem is they don't hold their wings in that tentiform position, they hold them out flat. So for me to get a good picture, I want to come in from the top. So I don't get to see that that good side shot. I mean, I could take the extra pictures, but what you'll notice is that the male's labial palps do not extend forward. In fact, you can see that there's this bushy region on the top of the head that he has, and that's just those palps coming back up, whereas hers are extended forward. There are also some maculation differences here, but I find that the position of the labial palps is, you know, the quickest way to make that determination of male or female for Palthus. All right, so now we go into another secondary sex characteristic, the androconia. And this is a general term that refers to elongated and very specialized scales that emit pheromones, sex-attractant pheromones. They can be single hairs. They can be a cluster of hairs, kind of tufted, sometimes called hair pencils. They can be located on the wing. For another species, they might be on the abdomen. They might be on a leg. So, and not all moths or butterflies have androconia, but it helps to know, do I even have a chance? Because if it's on the abdomen, you're probably not going to see it. They're covered in scales most of the time anyway. But there are exceptions where we can see evidence of the androconia. And the first example of that are what are called costal folds. What it is on the outside edge around the bend of the forewing. Think of like the shoulders, if you will. You have some excess wing and it's folded over. And when it folds over, it's hiding those androconia. So the fold is usually on the dorsal side of the wing, but there are a few moths where the fold is on the underside of the wing, hiding these sex sex glands, essentially. We find these in at least 3 families. I wouldn't be surprised if there are even more. The torts, the Paralides, and in butterflies, the Hesperidae, which are our skippers. And I was able to find a few particular subfamilies within each of those families that have these costal folds. I wouldn't be surprised if there are a few more. So let's take a look at a few examples. This is the lentiginous moth. It is a tort. And I am going to show you a zoomed in shot of that region. And if you look, do you see that there's like this crescent shape that is coming off of the side? That is the fold. Okay. So this is a male. Females never have costal folds that I'm aware of. Everything I've seen says it's only the males. Very common, another tortricid is the oblique-banded leaf roller moth. And here the costal fold is actually a darker color. So you got this little dark sliver that you would not see on a female in that particular species. And again, it's a costal fold that is hiding these androconia. Male again. This is a rare moth. Fewer than 10 have been seen in Maryland that I'm aware of, all out in Garrett County. I got really lucky seeing this one. It too has a costal fold. And in fact, you can see towards the bottom of where I've bracketed to highlight it, that it sits off of the side a little bit. So that fold kind of comes out as it folds back up over the top. So it stands out pretty nicely. Male again. Different family now, Paralides, Paralidae, the drab condylomia moth. What a name. Poor moth. It's called drab. Terrible. Terrible. Well, we had that, didn't we? There's a drab prominent moth. The comedian was right. Yeah. So the costal fold on this moth is very obvious and it's rather long. It really stretches a long distance along the costal edge of the wing. Take a look at the photo of the female. I think this might be the first time I've shown what the female would look like. You don't see anything that is folded up on the edge of her wing where the bend starts, right? So there's your male on the left and your female on the right. Do you have a question? Okay. I don't want to ignore the butterfly fans out there, so. Northern cloudy wing is one of our skippers, and I'm going to show you photos. I spent a lot of time trying to get good examples of skippers where the costal fold is obvious. It is very, very hard. These costal folds tend to show up best when the moth is fairly light colored, not dark. It just doesn't show as well. So you really need a good photo with good light to pick up that fold. Here we go. Well, I hope I can blow this up. Look on the right side especially. See that white line there? Okay, that is the edge of the fold coming up on the dorsal side. And you can see it a little bit on the left. Why do I know that that is a costal fold? I had to find a picture of a female. And when you see this picture, you'll understand what's going on here. So let's take a look at her. think that's as close as I can go in. Notice that the female has a lot of little white flecks on this brown wing. Those white flecks are never interrupted by a fold. Those white flecks go out to the very margin. So that's how I know that this is a female. And that the first one was a male with a costal fold. Oh, butterfly folks are going to get another one. And everybody know how to tell the boys from the girls for monarch? How do we do it?
Black on the left for the hindwing.
The black what?
Thicker splotch.
Yep. So those are black scales, but if you were to scrape off those scales, you have a scent gland underneath of it. And it's slightly raised as well.
No, the wing lines are very thick and black.
Correct. Yep. I agree with you. That's something that you would probably notice, with practice, but those scent glands, they're pretty obvious. So you are correct. Who's that again? Sorry about that. All right. Oh yeah, they're called scent patches as well. Oh boy, and you're getting 3 in a row. The old name for this moth was the sacum. It's now called Huron sacum, but it too has scent patches. And I've reversed things here. Now the male is on the right. See the black patch? It's a very large patch. That is a scent patch. So you have specific scales that release pheromones from that. The female, she has a dark patch, but I wouldn't call it black, and it's certainly not the same size. Okay. So there is his scent patch. Another feature in some moths' wings that we can use to tell the males from the females is called a fovea. And it is a spot on the wing where you have no scales. And I'd call it more translucent than I would transparent. And it looks distorted, like somebody tried to torch it or something. So that one is the pale-winged Chrysitophora moth. Looks a crambid. The female's on the left. And now, don't be confused. She has very shiny reflective scales. That's why you see a lot of pale areas on her wing. But look at the male on the right. He's got spots here and here. And look, you can see the distortion in the veins that surround that pale area. That is a fovea. And it's the easiest way to tell pale wing males from pale wing females. And then the last one I'm going to talk about is the freakiest thing I've ever seen in a moth. They're called coromata. And they are tube-like structures, usually in the abdomen, that are tucked away, tucked inside. But during the heat of passion, the males can inflate them, everse them, and they come out of the abdomen. And then they are used to disperse their own pheromones. Pheromones are not just a female thing. Males have their own pheromones as well. So this moth is called the salt marsh moth, and yet you can find it anywhere in Maryland. I don't know why they gave it that name, but this is the male of the species. He has much brighter abdomen, and the hind wings are different on him than the female. But when it's breeding time, early evening, all the males in an area will get together. You ever heard of a lek in the bird world, where prairie pigeons the males get together and they kind of show off their stuff. That's what these guys do. And here's what they look like. Oh my God. Who said ooh? I agree with you. That when I saw my first picture of this, I didn't know what to think. But those Coromata, they're huge, and yet they live inside the abdomen for the rest of the time. So the males, they all go out there with their Coromata exposed and they show off and they give off their pheromones, and the females will then be attracted to the area. There will be some mating taking place there, but what also happens is later at the night, now it'll be the female's turn. They don't have Coromata, but they will release their pheromones, and now the males will go and chase them. So it's a two-way street. Early in the night, the females are coming into the males, to the lek. And then later on the night, when they disperse and release their pheromones, then the guys go chasing the group. Wow, that's a very good question. When can they tuck it? Oh yeah. Yeah. Uh-huh.
That's the only moth that does that in Maryland? No.
This afternoon I found one more. I mean, not a live one. I wish. Pardon? That's a good question. I'm not sure if it's well, remember, they don't have blood, they have hemolymph. So I'm not sure if it's hemolymph or it is inflated by air. That's a good thing to research. No, the genitalia are still back here at the end of the abdomen. They're just out there for getting the message out. This is a very rare moth, but it does occur in Maryland. I think there are less than 5 contemporary records. Oh, there's a picture coming. Okay.
Somebody on Zoom is asking if that last one had a smell. Does it smell like sorry.
I don't know. It has some sort of smell that the females pick up on, but I don't know if they have a human smell. Okay, ready? I warned you. There we go. That's a moth. It is one of our Sicilian moths, or the clear wings.
It's not like a cool hummingbird moth.
No, because that is a sphinx moth.
The clear wing.
Yeah, there's a hummingbird clear wing that is not a true clear wing, but this is. Oh, notice the antenna. They're the clavate antenna, right? But it has, again, this eversible Coromata, a single one that just shoots right out of its butt. And it must wave it in the air when they're trying to attract a female. What's really cool is that some of these can be orange, like this one, and others, that Coromata is black. But as far as we know, no difference between the two.
Maturity, I don't know that.
Pardon?
Age or maturity.
Oh, that color difference? No, it's just two different morphs. Yeah. So, man, I know what's on my bucket list now is to find either this one or the salt marsh moth with those Coromata completely inflated out, because that is just freaky. Jason told me that there is a moth, I think it's Southeast Asian, and instead of having just 2 Coromata or 1, this one has 4. So when you look at it, you think, that's not even a moth. That's not an insect. That's just a freak. All right. I think we are nearing the end. And so I just wanted to offer some suggestions for online resources when you want to make IDs of your photographs. iNaturalist. I like iNaturalist. I didn't always, but I'm really growing to like it. It has both an AI-based component as well as crowdsourced identification. Then there's Bug Guide. And on Bug Guide, you get identifications from people who are subject matter experts. So they're pretty good, reliable identifications. LepSnap is it's really an app, but it's available for your PC as well. And that is strictly AI based. So here's my recommendation on the AI based IDs. They are not IDs, they are recommendations. Okay. Take that recommendation, and chances are it's right, but then I would go to a source such as Maryland Biodiversity Project. You can go back to Bug Guide. Did I have Bug Guide? Yeah, Bug Guide has plenty of information and other photos that you can compare what the AI is telling you this is and just confirm it. Moth Photographers Group, wonderful collection of photos, including a genitalia library. There, I said it. If I type that in. And then Moths of North America is a series of publications. And this is really academic stuff, but it's very, very well written. Problem is, only a few of them, the older ones, are available for free download. If you want to buy the fresh ones, get out your checkbook. They are not cheap. A website that I have found just in the last few months, and I'm really more impressed with it each time I go to it, is Moths of North Carolina. Yes, they're going to have some moths that we don't have, and we'll have some that they don't, but most of what we have here, you would also find on their website. And they got really good pictures and also descriptions of life history for each species. So with that, I do want to acknowledge Jason, the collections manager at Cornell, who allowed me to come up and pay him a visit for 5 days and go through their specimens. The bayberry geometer, that was courtesy of Jack Weissnant, one of Jason's assistants. And there were other people who allowed me to use their photos, and I want to acknowledge them, Jim Brighton and Bill Hubick, the co-founders of Maryland Biodiversity Project. Mark Etheridge and Tom Field. Oh, I spelled Tom's name wrong. It's F-E-I-L-D. Sorry. And to my wife, who is out there. Did I put you to sleep? Can you tell? Okay. She's still online, but that doesn't mean anything.
I'm here.
Oh,
I'm awake.
Oh, good. Hi. How's the wine?
It's good. Don't stay too long at the bar after the meeting.
Okay, I'll try not to. She is my #1 supporter. People think I'm crazy for going out at night and doing this, but she's crazier because she lets me do it. And she will even say, you know, the weather's good tomorrow. You can go out then. Like, man, I married the right girl. So with that, I will finish here and just take your questions either from the folks out there in Zoom land or those of you here live. What's our attendance tonight? It's almost 20. 20?
20 people, yeah.
Oh. Okay. Any questions?
There was a question in Zoom about how common is it that moths have similar or identical male and female?
Pretty common.
Pretty common.
Yeah. Certain families, it can be quite common. And then in others, you will see more differences. So
Somebody's asking how common it is that the male and female are the same.
Same in terms of their morphology, antenna, what they and it's often with the smaller moths. Yeah, but also the noctuids, the really large moths, that's where you almost always see some sort of differences when they're large, thank goodness. But it's the tiny ones that are pain. That's why they are the ones that people have to dissect to figure out what they have. But it's through dissection that we discover new species. And the other big thing is DNA analysis. New species are being discovered, like, well, I want to say every day, but I'll say every week. There's some new species being found around the world. And The number of moths in the world, I think, is officially 160, 170,000, something like that. And yet you talk to anyone such as Jason or others who study moths, and they'll tell you that number is probably closer to 250,000 or 300,000. There's so many moths to be discovered in very remote localized areas. And with DNA, we see that, hey, that thing that we thought was one moth, it might be 3 or 4 different species actually.
A couple of other questions. What has been your favorite moth or butterfly you photographed so far? And then Richard wants to know what kind of camera you use.
Okay. So the one that I photographed and just did a mic drop at that point, it's called the psychedelic Jones moth. I'm going to pull it up because it is a cool moth. Get him off my page. Jesus. All right, do a quick log in here. And when you see this moth, you'll understand why I wanted to see it and why I would have been really excited when I finally did. I know there's less than 15 records in Maryland, but to me, it's the wood duck of moths. It's really colorful. Bear with me a second. Okay. Jones. And there it is. Psychedelic Jones. Sounds like the Cheech and Chong. Sorry. Yeah. That was in Maryland, St. Mary's County. That's this moth is encountered so infrequently that we don't even know what the host plant is of this. Yeah. I think New Jersey is probably like ground zero for this species, but around here it's pretty rare. I'd have to collect it and dissect it. I let it go. I let it live another day. Pardon? No. We do not know that. I would think it has to do with sexual attraction. Okay. Yeah. But when I saw that, I said, I could just go home right now and I turn the lights off. No. If we figure out what the host plant is, then maybe we can figure out what the larva look like. What kind of camera? Canon TI5, but I'm looking to upgrade. I've had it for, I don't know, 7 or 8 years. It's showing its age.
And yes, this is native, right? Is that?
Psychedelic Jones? Yes, that's a native North American moth. Yes, ma'am.
Out at night, do you set up lights and sheets and all that kind of stuff?
Yes, ma'am.
What kind of lights do you use?
I use both ultraviolet and mercury vapor. So mercury vapor is a really bright one with the hopes that that is pulling things in. And then ultraviolet, I like to use the two because they give off 2 different wavelengths. So I will hopefully attract more. Some things might only be attracted to a certain wavelength, others coming into the other one. Yeah.
How long would it take you to actually start seeing the losses in what you set up?
Well, it takes about 45 minutes to an hour just to do the setup. And I'll say it depends. It's the cheap answer. I've had things show up within 5 minutes. And then other times, it might be an hour before I really notice things picking up. Some nights it can be really slow. And I've learned, don't give up. I mean, unless it's horrendous. Don't give up, because I've had nights where it was kind of slow. I'm thinking, just go home. Nah, stick it out. And at 1 o'clock, things start showing up. If you want to see a Luna moth, most Luna moths don't show up until around midnight or later. And I think that's because they probably eclose from their cocoons at roughly the same time each in the morning. And it takes a certain fixed, roughly fixed amount of time. And that coincides with midnight when they're capable of flying. I have seen them earlier, but 12 o'clock. I even told that to some guy who joined me last year down in Dorchester County one night. And I said, hey, if you want to see the loon, you got to stick around. And at 11 o'clock, he went home. Guess who showed up at 12:03? It was a male. Yes. No, go ahead.
Got it. Why are they attracted to the light?
Oh, that's the eternal question. There are a few theories out there. One that I've heard is that if you think before there were human lights, does that sound right? The lights that we turn on, there was only one light at night, right? The moon. And so when they see lights, they'll think that is the moon and they'll go towards it. I've heard people say that that's not true, that there are other reasons. But I don't know. Will we ever learn exactly why? Have to.
Little insects that go to the light also, and they think they're gonna eat them. I mean, is that part of it? No?
Not the moth. The moths do not eat. They do not eat other insects. In fact, a lot of moths. I shouldn't say a lot. Certain moths don't even have mouth parts. They don't eat anything. They have one thing on their mind.
That's why their lives are so short.
Oh yeah. Of the four life stages: egg, larva, pupa, adult. In almost, there are some exceptions. Adult is the shortest life stage. Yeah. Larvae are just feeding machines. That's all they do. They start out really tiny and then they get really big. And then pupa are just, they turn into mush and come out looking like a moth or a butterfly. Yes.
Find that the moonlight, and depending on which phase it's in, affects the numbers you get on the moth light.
I think it does, but it doesn't stop me from going out even on. Yeah. I know some people who do not bother to go out on a moonlit night,
Yeah.
but I've still had some good nights.